In this video, we want to look at how you take partial derivatives of functions. But before we get to that, let's just go back to taking the regular derivative when y is just a function of x. Suppose y is equal to 12x. Then we know that the derivative of y with respect to x is just the coefficient of x, which is 12. But there's different ways we could look at this problem. Suppose we wrote this problem as y is equal to 2 times 3 times x times 2, which of course is the same problem we had before, because 2 times 3 is 6 times 2 is 12, so y equal 12x. So if you were to see this problem and you were asked to find the derivative of y with respect to x, it's just the coefficient of x, all of the number that x is multiplied by. But in this case, some of those numbers appear after the x instead of just before the x. So we could write the answer as just the coefficient of x, all the numbers that x is multiplied by, as 2 times 3 times 2, which again is still 12. Let me show you one more way you could look at this problem. Suppose we say y is equal to, again, 12x, but I'm going to write it a little bit differently. I'm going to write it as 3x times 2 squared, which again is 3 times 2 squared, 3 times 4 squared. It's still y equal 12x, right? So if we were to look at the derivative of y with respect to x, you would say that derivative, again, is just the coefficient of x, since we only have x to the first power. And that coefficient of x would be everything that x is multiplied by, whether those numbers come before or after the x. So we could just write it as 3 times 2 squared, which again is the same answer we had before, 12 in all cases. Now let's try one more case. Suppose we said that y is a function of x, and let's say this time it's equal to 3x squared times 2 squared. And you were asked to find the derivative of y with respect to x. How would you do that? Well, again, I would just focus on this x squared right here, and then basically use the power function rule. So I know that I have x squared and I have some coefficient of x squared, which is basically the number that x squared is multiplied by. So using the power function rule, I bring down the 2 and multiply it by the coefficient of x, but here the coefficients of x are spread out. So I'm going to write 2, bring down the 2 times 3, rewrite the x, reduce the exponent by 1, 2 minus 1 is 1, and rewrite the rest of the coefficient of x. In this case, it appears to the right of x, which is just 2 squared. And so the answer would be, 6 times 4, 24x. Let's just try one more example. Suppose I tell you that y is equal to a times b times x squared times c times d, and a, b, c, and d are parameters. They're constants, they're numbers represented by letters. So how would you find the derivative of y with respect to x? The same way we did before. Only instead of having 3 and 2 squared, we now have letters in here, which are parameters a, b, c, and d. But again, we're taking the derivative of y with respect to x. So again, I just focus on the x squared term, and I take the derivative, bring down the 2, multiply it by the coefficient of x, 2 times a times b, take our variable x, rewrite it, reduce the exponent by 1, so it's x to the first power times c times d. Okay, if all of those examples made sense, partial derivatives should be quite easy. Let me give you an example. Suppose y is a function of 2 independent variables, x1 and x2, or it could be maybe x and w or x and z or something like that. An example would be maybe y is the salary of an individual, and a person's salary depends on his or her years of education, and maybe his or her years of experience or on-the-job training. And suppose this function takes the form of x1 times x2 plus x1 squared times, let's say, x2 squared. Okay, there's 2 partial derivatives we need to look at here. The first is the partial derivative of y with respect to x1, and then we need to look at the partial derivative of y with respect to x2. And when we look at the partial derivative of y with respect to x1, the symbol we use is partial y, partial x1. And that partial derivative sign, it looks kind of like a backward 6. But we read this expression as the partial derivative of y with respect to x1. We're looking at how y changes when x1 increases by 1 unit, holding the other independent variable x2 constant. So again, that's the key. We're letting x1 change and looking at its impact on y, treating x2 as a constant. So think of x2, wherever you see that x2, think of it as a number like 2 or 3 or 4 or something like that we're holding constant. So let's go to the first portion of y right here. What is the partial derivative of this first portion of y with respect to x1? Well, it's just the coefficient of x1 because we're treating x2 as a constant. So basically, you could think of this as x1 times 4. So what's the partial y with respect to x1? It'd just be the coefficient of x1, 4, which in this case is x2 because it's held constant at a number like 4. So partial y partial x1 is x2 plus. How does this second portion of y change when x1 goes up by 1 unit, holding x2 constant? So again, all I do is focus my attention on this x1 squared term, and if I'm looking at the partial y with respect to x1 holding x2 constant, I just view that x2 squared as some number like 3 or 7 or a number like c or d, something that's constant. It's the coefficient of x1 squared. So now I have to use the power function rule. Look at this portion of y, the partial of this portion of y with respect to x1. I just concentrate on the x1 variable, use the power function rule, bring down the 2, multiply it by x1, take the exponent of x1, the variable that we're differentiating with respect to, reduce its exponent by 1. 2 minus 1 is 1, so it's just x1 to the first power. And then just rewrite the rest of the coefficient of x1 squared. Remember, it's a constant like c or d or 3 or 4, so we have to rewrite that. We have to carry it through, so that's just x2 squared. Okay, now let's get the other partial derivative. Since y is a function of x1 and x2, we also have to look at the partial derivative of y with respect to x2. And what is that going to be? Well, again, remember, you have to recall what y was. It's equal to x1, x2 plus x1 squared times x2 squared. So the partial of y with respect to x2, go to the first portion of y. And now the partial of y with respect to x2 is just x1, because we're treating that as a constant now. It's just the coefficient of x2, plus the partial derivative of the second portion of y with respect to x2. So now treat that x2 squared term as our variable that we're differentiating with respect to, and think of x1 now as a constant. It's a parameter like c or d or a number 4 or 7. So partial y partial x2, bring down the exponent of x2, which is 2, times that coefficient of x2, which is x1 squared. Remember, we're thinking that as a constant, c or d or something like that, or some number, times x2. Now we have to reduce the exponent of x2 by 1. 2 minus 1 is 1, and there is your answer.